Likely on this video because you'd like to know how to differentiate and integrate functions with square roots in them, such as this one right here, the square root of 7x minus 2. In order to differentiate this, you're going to have to use the chain rule. So if you're not familiar with the chain rule, don't worry, I'll explain it right now. So essentially, all what the chain rule is this formula which I'm writing above right here. So it's essentially just, you have a variable u and y, and you just multiply the derivative of y with the derivative of u. And what you'll choose for u and y will be explained later on as well. So here you have it right here. What most examples in textbooks and online resources don't show is what the y variable is. It just assumes that you know that. So this could be very confusing for people who are just starting out. So first we're going to define what u is, and we'll just let u be what's inside the radical here. So this is going to be 7x minus 2, and we'll define y as this square root of u. And then with this information we can now put, d over du, square root of u multiplied by the derivative of 7x minus 2. And essentially this is just going to be 7. The 2 goes away obviously because it's just a constant. And then with the power rule, this gets rewritten as half u raised to the negative half power times 7. So before we progress any further, I'm going to explain why there's a negative half, and that's because you didn't have any power to start with. So when you apply the power rule of differentiation, what you essentially have is, so you have this just random term right here. So it's just going to be n times a x to the n minus 1 power, and that's where it comes from the minus 1. That's where your half comes from. And then also this invisible power is what got multiplied down here, so that's our n. Then n minus 1, negative half. So multiplied by 7. Eventually this should get rewritten as 1 over 2 times square root of u times 7. And then now what you're going to do next is bring the 7 into the numerator, and this becomes 7 over 2 radical u. And now you just substitute back your 7x minus 2 right here, and your derivative is 7 over 2 radical 7x minus 2. So that's your derivative. And now in order to prove this, we're going to do the integral of it. So now we're going to do the integral of 7 over 2 radical 7x minus 2 dx, and this time we're going to be doing what's considered to be the opposite of the chain rule, and that is known as u-substitution. So if you're not familiar with u-substitution, don't worry about this. So you have a variable u, but you don't have a y like this above here. So we're just going to let u once again be what's inside the radical as what we did upon differentiating this. So this is going to be u equals 7x minus 2, but here's where it's different. This time now you have the derivative of u, and as you know right here, derivative of u is 7, so we could just say this is 7 dx, and then obviously what dx is just 1 over 7 dx, because if this du is 7x multiplied by 7, whoops, it's a mistake right there. That should be du. Sorry about that. And then this eventually, this will be rewritten. As you see, you have right here, you have a little, well, I call it a constant. I'm not sure what's the proper term for it, but eventually, you bring it outside. Then, again, you put your integral sign. Then you just get what's inside the integrand. So this is just going to be square root of u. And now here's where it's different. You see this 1 over 7 du? That's what you're going to substitute for dx right here. So now you put 1 over 7 du. And you're also going to bring this out. So then this becomes 7 over 2, 1 over 7, integral sign, square root of u, du. And now there's one thing you could do here, which I'm going to do right now instead of later, is you could cross cancel right here. So this essentially becomes 1, this becomes 1, half times 1 is half, so this gets rewritten as half integral radical u du. And now this gets rewritten. You apply the power rule to this now, and the power rule to this will be, let's see, 1/2 u raised to the half power over 1/2. And the reason for this is because the power rule of integration, unlike the power rule of differentiation, is essentially the opposite. So what you're going to have right here is the integral of ax to the nth power. It's going to be ax n plus 1 over n plus 1. So you could see that rather than just subtracting your exponent and then multiplying the original value of the exponent, you're essentially just adding and dividing. So it's essentially just the opposite of what you do in the power rule of differentiation. So now with that said, what you see here is that you could also cancel out the halves, as you see in the denominator and in the constant outside. So you just cancel this out, and you're essentially left with u to the half power plus c, and this gets rewritten. This could be rewritten as, actually it should be rewritten as square root of u, and then now you just substitute u back, and as you see, u is 7x minus 2, so this eventually becomes radical 7x minus 2 plus your constant. And now when you compare this, you notice it's exactly the same as the original function prior to differentiation. Therefore, now we have proof that the derivative of the square root of 7x minus 2 is 7 over 2 radical 7x minus 2. As you see, integrating it down here led us all the way back to our original function, which is right here. And thank you for watching, and have a good day.